Hello. In today's video, we're going to be taking a look at the third and final type of transformations, reflections. We have three different lines here, and these lines represent our line of reflection, or LOR. You can think of this like a mirror. When you're given a question that involves performing a reflection, you're going to be given a shape on one end of the mirror, or you might be asked to plot a shape on one end of the mirror. Next, you're going to have your line of reflection, and we can see clearly, let's fix this line here. We can see clearly that the line of our shape here, we'll call it rectangle ABCD, is parallel to our line. This is the easiest type of reflection, where the actual line of reflection runs either vertically with the y-axis or horizontally with the x-axis. To create the reflection, we simply bunny hop and count the number of points between each of our coordinates and the line itself. So in this case, we have 4 points. And then we count that on the exact same side on the exact same line. We do the same thing for each 4. Now I'm not going to draw the bunny hop, I'm just going to count. So this is 4, 5, 6, 7. This is 4, 5, 6, 7. And since it's a rectangle, I know that my numbers are the same. So 1, 2, 3, 4, 5, 6, 7. And that's it. That is the simplest type of reflection to make when your line of reflection is either vertical or horizontal. Let's do one more down here. This time we have a triangle and a horizontal line of reflection. The principles are the same as they were up here. Everything here needs to be flipped. If you were, for example, looking into a mirror and this was your back, you wouldn't be looking directly at your back in the mirror. And if you are, well, you should probably talk to somebody about that. So we have to do the same thing. Count 1, 2, 1, 2. This is 4. And lastly, this is 2. And so the correct answer to a reflection like this is something that looks completely opposite. If I rotate my line, I can see that I have symmetry on both sides, and that's what you want. So not this, but this darker triangle here. Lastly, a diagonal line. A diagonal line in this case, which cuts through units exactly in half, we know to be 45 degrees. So this line of reflection is 45 degrees. We're going to start off with our shape over here. Put it way out there. Unlike the other lines of reflection where we could simply bunny hop in a straight line, for this one, we have two choices. We can bunny hop diagonally. Since we know that this line is 45 degrees, we can go exactly 45 degrees towards the line. Or, like a translation, we can make a bit of an L shape. So we're going to start this first point by doing the L shape. So we can count across. 1, 2, 3, 4. 1, 2, 3, 4. And so I know I have to do the reverse move. I went over to the right and down. In this case, 1, 2, 3, 4 to the right. 1, 2, 3, 4. And there we are for our first point. Now for this second point, we're going to do this diagonally. So we're just going to count straight to our line of reflection. 1 diagonal, 2 diagonal, 3 diagonal, 4 diagonal, 5 diagonal. I'll do the same thing on the other side. 1, 2, 3, 4, 5. For this one here, I'm also going to move diagonally. 1, 2, 3, 4, 5, 6 and a half. This is important. We can't count this as a whole because it's not an entire unit. Half, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5. Now, I take my ruler, or in this case my protractor, I recreate my shape, and to check that I've done this correctly, I'm going to actually rotate this as though it were a vertical line, and we can see that we have symmetry. We've got some angry eyes going on here. Now, the last type of reflection I'm going to show you, we're going to do down here. We're also going to use a 45-degree line. But this time, we're going to use a shape that overlaps the line of reflection. You can think of this like a ghost reaching out through the mirror. Now, you might be thinking, well, okay, well this is easy, it's 45 degrees, you just showed us how we're going to make lines going this way, but what do we do with these points over here? Well, what we do is we actually make them go the other way. So if I do these ones real quick, 1.5, half, 1, 1, 2, 3, 1, 2, 3. I'm now going to take these and go in the opposite direction. So this is 1, 2, 1, 2. This is a half, and so I only go over a half. And what I'm left with is an overlapped reflection. Again, the easiest way to check if it's correct is to measure the original shape. So this original shape was 7 units tall and 3 across. My new shape is 3 across and 7 tall. And if I turn my diagonal line vertical, I can see that I have symmetry. Once again, I've been Mr. Ford, and this has been how to do the third type of transformations, reflections.